This next and last section is entitled Cramer's Rule. Cramer's Rule is yet another method of solving system of equations. In this case, using determinants. If you have x plus y is equal to 3, that is 1x, 1y equals 3, and maybe 3x minus y is 1. How can you solve this? By using Cramer's rule. X is going to equal a division of two determinants. Y is going to equal a division of two determinants. For x and y, the denominator determinants will just be the coefficients. 1, 1, 3, negative 1. 1, 1, 3, negative 1. In fact, the tops are going to be the same, with one exception. The tops are going to be the same, with one exception. If you're solving for x, don't use those numbers on the top. Use the right-hand numbers. For the first column, the x column, and then the y column. For the x column, don't use the numbers in front of x. Use the right-hand numbers. You want to solve for y? In the top, remember, first column is x, second column is y. How do I know? Because the first column says x, and the second column says y. If I had written 3y plus 2x is 9, and 3y minus 24x is 11, well, those would be y numbers. The first entries, first column would be y's. Okay, whichever comes first. X happened to come first. So the first column is x, and then y's came up. So, since I'm solving for y, I don't use the numbers in the numerator. I don't use the numbers in front of y. I use the right-hand numbers. 3, 1. Okay, this determinant is negative 3 minus 1 times 1 is 1. That is, the top is negative 4. And the bottom is negative 1 minus 3, which also is negative 4. Divide the same numbers, get 1. What is y equal? These two numbers multiply out to 1 minus these two numbers multiply out to 9. 1 minus 9 happens to be negative 8. Now, the denominators don't change. So I already know it's negative 4. You want to do it again? Fine, but please get the same answer as you got earlier. Use it as a check if you want to say negative 1 minus 3 is negative 4. It's not a big deal if you got negative 5, but then realize that one of these, if not both of them, are wrong. Let's try another one. The denominator determinants for x and y and z will be the coefficient determinant. To solve for x, for the numerators, be solving for x, replace the right-hand numbers in the x column. You want to solve for y, replace the y coefficient numbers with the right-hand numbers. If you have 2x plus y is 5, and x minus 3y is 6, well then x is going to equal the division of two determinants. The bottom determinant will be the numbers in front of x followed by the numbers in front of y. Always including the signs. The numerator. Since I'm solving for x, I don't use the first column with x's. I use the right-hand number. Right-hand numbers. And for y, it's 1, -3. You multiply those numbers, you get -15 minus, multiply those numbers, you get 6. The bottom. You multiply, you get -6 minus, you multiply, you get 1. Get -21 over -7, better known as 3. So x is 3. What is y equal? The numerator, you put the coefficient of the numbers in front of x first, and then instead of the coefficient in front of y's, since we're solving for y, instead of the coefficients in front of y, put the right-hand numbers. And the bottom is going to be the same. That is, it's going to be -7. Okay, the bottom is -7. 2 times 6 minus 1 times 5. That gives you 7 over -7 or -1. So y equals -1, x equals 3. If the bottom happens to be 0, then the system of equations is inconsistent. And you can't use Cramer's rule to solve it. Remember? Oh, if it's inconsistent, there is no solution. Sorry. I have a problem with that. It can be inconsistent or dependent. Yes, of course. It can be either or. It doesn't use the right-hand numbers. All right, now let's suppose you have 3x plus 2y plus 4z is equal to 9. 2x minus y plus 2z is equal to 3. And x plus y minus z is 1. We're going to solve this system of equations using Cramer's rule. Well, this time we have 3 variables. X, like always, is the division of 2 integers. 2 determinants, excuse me. The bottom determinant is the coefficient matrix. 3, 2, 1 for x, 2, -1, 1 for y, 4, 2, -1 for z. And the numerator one is going to be exactly the same. Except, and there better be an exception, because whatever the bottom determinant is, if the top one is the same, you divide the same 2 numbers, you get 1. Since I'm solving for x, the x column in the numerator only gets replaced with the right-hand numbers. 9, 3, 1. And then we use the spaghetti method for each of these determinants. 9, 2, 4, 3, -1, 2, 1, 1, -1. We repeat the first 2 columns and we spaghetti. We get 9 plus 4 plus 12. We get 25 minus -4 plus 18. You have to know how to multiply. -6. If you take away 6, excuse me, if you take away 4, and then you take away 6, you took away 10. Well, if you have 18, you take away 10, you have 8. 25 minus 8 is 17. Now, you have to do the bottom determinant. Let me do that up here, please. 3, 2, 1, 2, negative 1, 1, 4, 2, negative 1. Repeat the first two. 3, 2, 1, 2, negative 1, 1. You get 3 plus 4 plus 8 minus negative 4 plus 6 minus 4 for that one. You get 15 minus a negative 2. You get 17. And 17 over 17 is 1. And now we know the bottom determinant is 17. It won't change for x, y, or z. No matter how many variables you have, it won't change. And to use Cramer's rule, the number of equations has to match the number of rows. Okay. Now, if you want to solve for y, we know the bottom determinant is 17. The top one, we put the coefficient of x's. Instead of the coefficient of y's, we put the right-hand numbers, 9, 3, 1, and 4, 2, negative 1. On the side, we'll figure out what this is. 3, 9, 4, 2, 1, 3, 1, 2, negative 1, 3, 2, 1, 9, 3, 1. You get negative 9 plus 18, which is 9, plus 8, 9 plus 8, 17, minus 12 plus 6 is 18, minus 9. 18 minus 9 is 9. 17 minus 9 is 8. So you get 8 over 17, which I think is not correct. So let's see if I made a little mistake. Then the answer isn't what I thought it would be. Oh, but it is. No, everyone is screaming because they all see my mistake. Let me try it again. Three, 2, 1 is the coefficient of x. Since I'm solving for y, I put the right-hand numbers, and z, I put the z numbers, 4, 2, negative 1. And I repeat the first column, and repeat the second column. 3 times 3 is 9. I get negative 9. 9 times 2 is 18, plus 18, plus 8, minus 12, plus 6, 18, Oh, minus 18. So that's 0. And this is 17 minus 0, which is 17. Excuse me. And of course, 17 over 17 is 1. Now we want to solve for z. The bottom determinant is always the same. So make sure if you only calculated once that you didn't make a mistake. Z is a division of two determinants. The top one, well, first you have the coefficient of x's, 3, 2, 1. Then you have the coefficient of y's, 2, negative 1, 1. And then you have the right-hand numbers. In the bottom, 17. So it's just a matter of calculating that top determinant. 3, 2, 1, 2, negative 1, 1, 9, 3, 1. Repeat the first column and then the second column. The first column, the second column. And tic-tac-toe. Those numbers multiply out to negative 3. These numbers multiply out to 6. These multiply out to 18. Minus negative 9. Positive 9, which is 0 so far, plus 4. So that second bracket is 4. And the first one is 18 minus 3 is 15 plus 6 more is 21. 21 minus 4 is 17. So you get 17 over 17, which is 1. It's exactly what the answer was supposed to be. X, y, and z all equals 1. Okay. Bottom determinant is always the coefficient matrix. The top, and that's in all three, that's in all for all the variables, whether there's 9 variables or 7 variables or 2 variables. Now, for their top determinant, you want to solve for y, you keep the coefficient of x the same as the coefficient matrix, the coefficient of the z the same as the coefficient matrix, but for y, you put the right-hand numbers. For z, you put the right-hand numbers. For x, you put the right-hand numbers. The other two columns are the same as the bottom. Okay, this completes the section on solving system of equations using Cramer's rule, and it's the end of the video. Hope you enjoyed the video and that you're doing quite well in your Matrix Algebra class. Thank you.